Hello friends, welcome back to another video. So today in this video we are going to learn the initialization process, which is a very basic and fundamental process that you come across when you are performing DFT calculation. So in the previous video we are working on RB2 SNCL6, and in this video we're gonna work on this material as well. So we have created the directory AO1, and this is our structure that we have created in the last video. So if you want to learn how to create structure in WIEN2k, you can go back to that video. So we are working on terminal, so we can just open the terminal, and now we're gonna start the initialization process. So before you begin the initialization process, it is recommended that you should check for the space group. So in the last video we have applied the space group, so we are good to go. So we're gonna start the initialization process with this command, init_lapw. So here they are asking for the reduction. So we are not reducing anything in the compound so far. So we're gonna press 0 here, and now it's asking for the schemes. I recommend using new scheme, but it's subjective. You can use the old scheme. So now it has defined the RMT values. So in this video we're not gonna dive deep into the concepts. We're gonna focus on the process itself. So because it's a computational work, so you have to practice it a lot to get used to the process, and then when you are good to go with the process, you can learn each and everything in it. So here it has defined the RMT values. You can consider it the area we are the space where we have performing the calculations, like RB has its own area, SN has its own, and similarly the CL has its own area. So here it's asking that you do you want to accept these radii, discard them, or rerun the set RMT for yourself. So it is recommended to let the software decide what our RMT value it have to use. So I'm going to accept this radii. Now it's asking for the bond length. What should be the bond length that their movement and radius or RMT do not overlap? So it is recommended to use 2. So we're gonna just use 2 here. And now it's asking for the space group. Are we good with the previously given space group? Yes, I am. So I'm gonna just press C to continue. So now it's asking for the symmetry of the structure, or we wanna edit anything. So I don't want to edit anything, so I'm going to just press C here, and now continue with L start. Yes, and now this is the crucial part. So it's asking what our material is. If our material is magnetic, we should use up or minus down. If it's non-magnetic, we should use minus NM. So if our material is non-magnetic, we can choose NM. If it's magnetic, we could choose up, we could choose down. And in magnetic there are three types of basically magnetic materials. One is ferromagnetic, other is ferrimagnetic, and the third one is anti-ferromagnetic, AFM. So if your material is ferrimagnetic, you have to choose minus ask and go down there and make some changes there. If your material is anti-ferromagnetic, you have to also go to the minus ask and do some changes. When we work on magnetic material, we're gonna go through this process. So as I know that my material is non-magnetic, so I'm gonna just type minus NM here. So here it's asking for the exchange correlation functionals, which is the crucial part in DFT. So I'm gonna use WCGGA for this video, and now it's asking for the to check the core charge that it shouldn't leak out. So I'm gonna use -6, which is recommended. Now it's asking for the K points, how many K points you want to generate. Basically this is the space around which you have to calculate your quantum mechanical simulation. So I'm gonna continue with it. So more k points, higher accuracy, but at the same time cost you more computational power. So I recommend using, if you're performing for the very first time, you should go with the 50k points, which corresponds to the mesh of 333, 3 cross 3 cross 3. And I'm gonna continue with restart. So now it's asking us, do you want to perform spin polarized calculation? No, I don't want to perform spin polarized calculation because my material is non-magnetic. So I'm gonna just press N here. And now when you see this, that this prompt or this text showed up like INIT LAPW finished, okay, it means that you have performed your initialization successfully. And now there are two things that you have to look for when you perform your initialization process. VI, which is the view, AO1, because we are in AO1 directory, and we're gonna search IN1. It's a file, and here you have to make two changes here. One is RMT cross Kmax and the other is Lmax. If you increase the value, you get better results, but at the same time cost you more computational resources, just like the k points. Similarly, other file is IN2, and if you increase the Gmax, you get a better picture and you get better results, but at the same time cost you more computational resources. So this is the overall initialization process in WIEN2k. So I will make videos in the future on each and every concept that is important in initialization process that you have to learn, and it will help you build an intuition. And I believe if you have the intuition is the key component or the fundamental component in learning physics. So see you in the next video. Till then, take care. Peace.